All right. So just as so last week we started on chapter 5, which was on patterns, right? So things like different repeating patterns, how we can take a seemingly really long problem, things like adding all the numbers from 1 up to something. We can take things like that and we can simplify them. We can make them easier to understand. We can make them easier to, I guess, kind of the word would be make them easier to digest, right? So that everyone can follow along without too much of an issue, hopefully, right? So let me see over here. But before we continue on patterns, I just want to double check with all of you guys. Uh, are you like, do you guys have any questions on any of the previous topics that you would want me to go over?
I have a I have a question about the one about finding area of triangle.
Area of triangle, sure. So in terms of area of triangle, do you mean just like any triangle?
Like the one where you had the like super long formula one.
The super long formula one. Okay, I think I know what you're talking about. So, uh, the that means that the triangle that you're talking about in that case, this is where you're given a triangle, but you're not told if any of the sides are the same. All you know is, let's say, one side that we label. So let's say this is triangle A, B, C, right? So let's say that this side, and this side. Well, let's assume that we know the lengths of each side, right? So we have we're told that, let's say, A is 10, B is 4. Let's see. This one can't be too big, so let's do 5. So A plus B. Let's refer back to our restrictions, right? So when we go to over here, let me go to that page. I believe it should be near the end of 3, I think. As we do Pythagoras first. Let me just make sure I go back, and I just want to make sure I find the correct page. All right. So over here we are given the formula. So there's 2 parts to these formulas, right?
Sorry, Clinton.
Yes.
So you're talking to Lucas, right?
Yes.
But why Lucas not listen? Lucas, what are you doing right now?
I was just closing my door.
So the teacher only teach you for this question, for your figure out your problem, and you're not focused. That's not good.
Okay.
Sorry, Clinton. Continue.
Okay.
Don't forget to recording. Okay.
Oh, I am.
Yeah.
Okay. Yeah. So what we're gonna do here is essentially we're going to be using the formula is called Heron's formula, right? So this is where you're told that the area for any triangle is equal to, this is a really long formula, S minus A, S minus B, S minus C. And so A, B, and C, these are the lengths of each side of a triangle, right? S comes from a different formula. So S is equal to 1/2 A plus B plus C, right? So A, B, and C are the same in both of these formulas, right? And you need both of these formulas on any particular triangle, right? So keep in mind there are specific conditions for you to have to satisfy in order to use this. The condition is you need to know the lengths of each side, right? If you don't know the lengths of each side, you cannot use this formula. You may have to approach it in a different way. But in this case, I know that A is 7. I know that B is 4. I know that C is 5, right? So what you can do is you can plug in all the values that you know. You should start with finding out what S is, right? So in the first case, S is equal to 1/2 A, which is 7, plus B, which is 4, plus C, which is 5, right? So this is 1/2. 7 plus 4 is 11. 11 plus 5 is 16. So this is half of 16, which means that S is 8. Right? Everyone following along so far? Now that we know S, I also know what A is, I know what B is, I know what C is. So I basically know all the variables I need.
I have another question.
But what do you mean by other question?
Like I don't get I was writing down the formula and I didn't get the part where you said how B became 7.
B is not 7, B is 4.
Oh no, like the one at the top. That's 4.
One at the top. You mean this?
Can I draw to show you?
Yeah.
It's like this one.
Oh,
That's
this is just labeling the different corners of a triangle.
okay. So then B is always gonna be 4.
No, I'm saying for this particular triangle, if
Oh.
B is 4, A is 7, and C is 5, right?
Oh yeah.
So
Okay.
it's gonna depend on the triangle, but yeah. So it's not gonna be for everyone, right? So this just means that this is triangle ABC, right? So now that I found out what S is, and I also know what A is, what B is, what C is, I can use this second formula now. So A is the square root of S, which is 8, times S minus A, which is 8 minus 7, times S minus B, which is 8 minus 4, times S minus C, which is 8 minus 5. And this is all square root. Right? So this becomes 8 times 1 times 4 times 3. Right? And then this gets simplified to square root. So 8 times 1, this is just 8. And then 4 times 3 is 12. 12 times 8, 96. Right? And then here we're going to have to go through into our calculator because 96 does not give us a nice square root. So if I do 96 and I set the square root of 96. So remember I previously said that you only have to give up to three decimal places, right? So I can say that 96 is approximately equal. So remember the little dot on top of the equal sign. This is going to be approximately equal to 9.798 since I'm rounding to the third decimal place. Right. And then because I have solved this formula, what this means is that the area of this triangle is 9.798. Does that make sense? Just keep in mind that this formula only applies if you know what the length of each side is, right? If you don't know what the length of each side is, you're going to have to do some other things to try to figure it out, like whether or not it's a right angle triangle, whether or not you know any of the angles or anything like that.
Well, what if we don't know any of the sides? Then how do we find the area?
Well, if you don't know any of the sides and you're not told what any of the angles are, then it's impossible, right? If I
So you
just
can't find the area if you.
if I draw a completely random triangle, right, and you don't have a ruler, you don't have anything on you. If I just draw a completely random triangle and I told you to find the area, you can't do that because I haven't given you any information, right?
For example, if you drew like an angle, like a triangle that you have right there, and then you have one angle, and then if you had just one angle or maybe two angles, how do you find the area?
That's gonna utilize formulas that I don't believe you've learned yet. That's gonna use sine, cosine, and tangent. Okay. So we don't have to worry about that just yet. Right. So far we're only gonna be focusing on more of the simple cases where you know either all the sides or you're told what the angles are, or the triangle is a special type of triangle, whether it's like an isosceles, whether it's an equilateral or a right angle, right? So those are usually gonna be the things we're gonna be focusing on, right?
And so if we were in the contest and we were given the test, it would include this, and I also include isosceles, right?
It could be pretty much any triangle, yeah.
Okay, then I don't really know how to do isosceles.
Well, isosceles is also going to depend on what information are you given about the
Isn't
isosceles triangle.
isosceles have like two same angles and then one that's different?
Yeah. So two angles are the same, or two sides are the same length, and the third one is not the same.
So like, isn't the test gonna be multiple choice?
Yeah.
Like, is that gonna be like those ones? Because this is also a Gauss.
It's gonna be similar to that, yeah.
I believe this was the one from the last year. Not sure.
Did anyone else have any questions about any of the previous topics? Right. So far we've gone through things like numeracy, geometry, measurement, and basic problem solving. Right. We just got started on patterns. I believe we left off at page. I believe we stopped before 5.2. Right. So we only went through the first part of chapter 5, which was, I think the topic was called keeping it simple. Right. So here, the next part. So if you just as kind of a recap of what went on previously. So previously we learned there are some patterns in terms of numbers, there's some patterns in terms of sums, right? So if I were to say, so let's look back at one of the previous questions, right? Where it was, what is the unit digit of 2 to the power of 100, right? So it's essentially asking you what is the digit on the far right side of this, right? And then here, what you had to do is you had to discover and apply some sort of pattern. So we know 2 to the power of 1 was 2, 2 to the power of 2 was 4, 2 to the power of 3 is 8, power of 4 is 16. So here we're only looking at the last digit. 2 to the power of 5 is 32, 2 to the power of 6 is 64. So this repeats. It goes from 2 to 4 to 8 to 6, and then it goes back to 2, right? So we have a repeating sequence of 4 numbers, right? These 4 numbers are constantly repeating again and again and again. Right? So what we had to do was, I know that every single group of 4. So another way of writing this is I can say 2 to the power of 1, 2 to the power of 2, 2 to the power of 3, 2 to the power of 4. The last digits are going to be the same, where this is 5, this is 6, this is 7, this is 8, right? And then 9, 10, 11, 12, right? I can safely say this because this follows a pattern, right? So if I look at this last digit, these are all multiples of 4, right? This is 4 times 1, 4 times 2, 4 times 3. And if I kept going, it's the same. So what I want to do first is, obviously I'm not gonna keep writing this until I get to 2 to 100. Right? That's just a waste of time. So what I want to do is I want to follow this pattern. I want to know, well, 2 to the power of 100. What is the closest multiple of 4 to 100? Well, as it turns out, 100 is a multiple of 4. Right? So what that means is that because it is a multiple of 4, I know that it's going to show up in this column. So I know that further down the line, 2 to the power of 100 is going to show up over here. Right? These are 2, 4, 6, 8. So with that being said, is I can say that 2 to the power of 100, the very last digit, the ones digit, is going to be 8. Because it follows this pattern. Right? And you can see how much work we saved ourselves. Right? We notice a pattern, we broke it down into a simpler question. Right? And then from there, we're able to solve the question without having to do an unnecessary amount of work. Right. And then we also kind of went over things like if you wanted to find the sum of all odd numbers up to a certain point, that could easily be done by taking basically the sum of the first n squared. The first n numbers is n squared. Right. This is for odd numbers. So if it's like 1, 3, 5, 7, if you added all of these together, you would get 16. There's 4 numbers here. The sum is n squared, which is n times n, which in this case 4 times 4. Okay. So the next thing we're going to do, so this is like a very odd case, right? Because what are the chances that you're going to be told to add uh only like the first odd numbers, right? What are the chances of that happening are quite low. So the next part that we're going to go over is section 5.2. This is on page 69 in your textbook, right? So 5.2 is the topic sum of consecutive positive integers, right? So the word consecutive, it means that each number comes immediately one after another. So if I start with 3, the next consecutive number is 4. And then the next consecutive number after that is 5, and then so on and so forth, right? So over here it says, one of the most famous stories about finding a pattern is associated with the accomplished mathematician Carl Friedrich Gauss. In the school life of young Gauss, teachers often gave students complicated calculation problems. One day, so the story goes, a teacher gave the class the task of adding up the integers from 1 to 100. That is, finding the sum 1 plus 2 plus 3 plus 4, etc., up to 100, right? Unfortunately for the teacher, Gauss, age 10, was a student in the class and after only a few moments gave the correct answer. Needless to say, the teacher was surprised and challenged young Gauss to explain how he determined the answer so quickly. He explained that when he looked at the list of numbers to be added, a pattern became evident. So if you look at the little diagram below, you can see an arrows are connecting two numbers together, right? 1 with 100, 2 with 99, 3 with 98, so on and so forth, right? So note that 1 plus 100. So if you start with the outer edge, the first and the last number, and you added them together, you got 101. If you then moved in one number and you added those together, you also get 101. So 2 plus 99 is also 101. 3 plus 98 is also 101, so on and so forth, right? So Gauss wrote down the sum and underneath it wrote the same sum, but in reverse order, and he added the two rows, right? So if you look on page 70, you can see that he wrote down the numbers 1 to 100, going from smallest to biggest. Then he wrote down all the numbers from 100 to 1 in like biggest to smallest order. If you add top to bottom, you would always get 101. So what that means is that another way of looking at it is we are essentially adding 101 to itself a certain number of times. Right. So the sum of matching pairs is always 101. Since there are 100 numbers in total, the sum of 101 plus 101 plus 101, etc., becomes 100 times 101. Does that make sense? So, however, because he did this, right, he wrote the numbers 1 to 100 two times in order to add them, right? One time when he was going from smallest to biggest, another time when he was going from biggest to smallest. So because he wrote all of the numbers twice, he added the sum twice, right? He added all the numbers together two times. So in order to determine the answer, So the sum of 1 plus 2 plus 3 plus 4, etc., etc. So the sum of all these numbers is equal to 100. This is how many of those matching pairs there are, times 101, which is the sum of each pair, divided by 2, because because they use the numbers twice. Does this make sense so far? Right. So we've learned, or you should have learned before, how to like simplification in terms of mathematics, right? So this is 100. This is 2. I can simplify these, right? This simplifies to 50 and 1, which means this is the same as 50 times 101, which is 5,050. So what this means is that if I start with a number 1 and I add every single number together to get up to 100, we end up getting 5,050. And you can actually, if you want to waste the time, you can double check this. Right? You can press the addition button on your calculator, you can add everything. You can do all of that up to 100, and you'll see that you do get 5,050.
Clinton, I have another question.
Yes.
There is this, like, I'm gonna have to kind of draw on it.
Sure.
I have to show you something. So there's this trick with multiplication where you can do, like, for example, 23 times 42. Don't mind my writing. I'm writing on a trackpad. And then you can take, like, the first number of, like, the tens and times the 10, so that's like 8, and then somewhere like 3 plus 2 equals 5, and then you add it to 8. Like 5 plus 8 is, I'm so bad at addition. I don't know, somewhere in the tens, and then you write the answer of that. What is 5 plus 8? Oh, it's 13. So like it's like that. It's somewhat like that. Is that even the right answer?
No.
Yeah, exactly. I knew it wasn't right. Well, there was this trick where you could do that and then you would get it right.
Okay.
And then I saw it online and then I tried it. I punched it into a calculator. The calculator said it was right, but when I tried it myself, I got it wrong.
Interesting.
So do you think it's? Have you tried it before? You can search it up online. Maybe you can try.
I can take a look at it. I'm not sure exactly which one you're talking about.
Like
but yeah, for sure I could take a look at it.
Yeah. Thanks.
So, if we look on page 50, the exercise 15. So, page 50, or sorry, not page 50, sorry. Page 70, number 15. It says use Gauss's method. So use the method that Gauss used to find the sum of the sum of all the numbers starting from 1 up to 16. Right. Don't use a calculator. Don't plug this into a calculator. Don't add the numbers one by one, but like don't add the numbers one by one in your head. Use Gauss's method to help you. Right. So if you had numbers like 1 plus 2 plus 3, and then you did the same, but you started with 16.
Isn't it like 17?
Yeah. So each matching pair gives you the sum of 17.
So you can take 17 times 16 divided by 2.
Yes. What is that?
Give me a minute.
So we have the sum of each matching pair. We multiply it by how many of those matching pairs there are, and we divide it by 2 since we're adding the numbers twice.
I have the answer.
What is it?
130. 136.
136. Yep. Right. So since this is quite a bit of a shorter question, you could pretty much just like plug in all the numbers in a calculator and just double check, right? So for example, if I shared this and I went to calculator over here, right? I have 1 plus 2. You get 136, right? This is relatively shorter, which is why I use a calculator to show you. But you can confirm these are all the numbers from 1 to 16. Gave us 136 as an answer. Right. So next one. What about if I asked you to find, so this was A, part A. What about if I wanted you to do part B? So let's do this way. Lucas, can you do exercise 15B? Justin, can you do C?
Is it like the sum of the first 50 consecutive positive integers of out of infinity? Or like how many numbers is like first?
It just
1
says
to
sum of the
50?
first 50. So 1 to 50.
Oh. Well, that shouldn't be too hard.
Is the answer to C 20,100?
Let me see. What does it say? Sum of the first 200 consecutive positive integers. Let me just calculate this really quick. So there's 200 matching pairs. Each matching pair gives you a sum of 201. You divide that by 2, 20,100. Yeah. Excellent.
I feel like mine has decimal.
You shouldn't get decimals. We're
Because
adding only whole numbers together.
I did division and then I first did multiplication by doing 51 times multiplied 50, and then I got 2,550. That's right for the multiplication, right?
Hold on.
2,550 for 51 times 50.
No. Oh, did you say 2,550?
Yeah.
Yes, that's right. Yeah. And then divide that by 2.
Yeah, I did that, and then
You shouldn't get decimals.
I did 2. I did the first number, and I put 1 at the top, 2 at the bottom. Then I dropped the 5 from the top, and then I did 2 again at the top, and I got 4. 1, and then I dropped the 5 again, and I put 7 for 14, and then there's 1 remainder. So I put decimal in there.
That shouldn't be the case.
You can try it. Maybe I'm wrong.
Get 1,275.
I just need to remove the decimal, that's all. I'm oh,
So just yeah. So if you think about it, we're only adding whole numbers together, which means that we should never be getting decimals, right? Yes, we are dividing by 2, but this is the sum of just adding whole numbers, right? Perfect.
so the answer is 1,275.
Yeah. So over here there comes a question, right? So does the same method work if you have an odd number of consecutive positive integers, right? So all the ones that we've tried before, we've done first 16, first 50, first 200. These are all even numbers, right? 16, 50, 200. Does it still work if there's an odd number, right? So if you were asked to find the sum of, if we look at exercise 16, it's 1 all the way to 11, right? So let's try. There are a total of 11 pairs. If I wrote 11, 10, blah, 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 down over here, each pair gives 12 as a sum. And let's try dividing this by 2, right? So simplify, you get 66, right? And I can double check this. If I were to open a calculator, so 1 plus 2. Seems to work. I add all the numbers starting from 1 up to 11, and I get 66, which is what I also got when I applied the normal formula. Right? So we can double check. Does this work for the sum of the first 75? This is another odd number. Right? So 1 plus, whoops, 1 plus 2 plus 3, blah, 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 75. Then let's say I rewrote 75 over here.
Well, then I have another question.
Yes.
Kind of off topic. How large is your monitor?
27 inches.
Is it $144?
What do you mean by $144?
$144.
I don't remember what the price was.
Probably 144. Never mind.
Right. This should give 2850. Right. And then I guess what we can do, sum of first. So a quick Google search, because I don't want to type this into a calculator, will confirm that the sum of the first, well, I'm not sharing. This will confirm that the sum of the first 75 natural numbers, which is 1 to 75, is in fact 2850, right? Which is what we just calculated. Right. So it does seem to work. It doesn't matter if there's an odd number of terms. So if there's an odd number of numbers, doesn't matter if it's an even number of numbers. as long as those numbers are consecutive, and that's the most important part. Consecutive means that every single number comes right after another one. Right? This formula does not work if all of a sudden I wanted to add all the numbers except for 3. Doesn't work. Right? If you're missing a number in between them in such a way that the numbers, instead of having a difference of 1, they have a difference of not something other than 1. So the work of Gauss can be extended to the sum of any list of consecutive positive integers, such that you have the first term, which is the number of consecutive positive integers. So that's how many numbers you're adding, multiplied by the first number plus the last number. This is how we get our matching terms, the sum, right? 1 is the first number, 75 is the last number. When we add both of these together, we get 76 in this case, right? And this is all divided by 2, right? So over here, if we look at page 71, so did you know that mathematicians use algebra to simplify the task of writing long instructions? Based on our work alone, the sum of the positive integers from 1 up to a certain number n, or in the short form Sn, right? So Sn means the sum from 1 to n, where n is a variable, it's a number, right? It could be 10, it could be 1,000, it could be 100, who knows, right? The formula for the sum of all of these numbers is given by this, and it says that it's n times n plus 1 divided by 2. The number of terms multiplied by the number of terms plus 1 divided by 2. And you can check that this is the same as what we've done, right? When I did the number was 75, we found that the sum was equal to 75 times 76. But 76 comes from the last number. Whoops. Comes from the last number plus the first number, which is always 1, divided by 2. So if I were to replace how many numbers, if I were to replace this with n, this is exactly the same as this. So don't worry about this. A lot of these formulas, well, this one I'm not 100% sure, but when you're doing the contest, you're going to be given a formula page, right? So you do not per se have to memorize every single formula. That being said, though, they don't give you every single formula, right? They gave you all the major ones, like what are the formulas for area of this, volume of this, blah 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 blah. But whether or not they're gonna give you like these really really small formulas that you'll need, up for debate, right? They might, but they also may not. So it's always better to have it memorized if possible. Otherwise, I don't know, right? You can test your luck.
But then I have a question for the contest.
Yes.
For the contest, I've done Gauss's like their um their past tests. I have a teacher that prints them for me. They're online. I see that the question that they have, they go from easiest to hardest.
Yes.
So then when I'm doing the questions, they're like after 20, they're like very hard, right?
Yes.
Okay.
Yeah, contests, they're usually split up into like 3 sections, like section A, section B, section C. All of them are multiple choice. A is easier than B, B is easier than C. right? However, C is obviously worth more points.
Will it be hosted on Discord?
I don't know about that.
Oh,
So
so
the specifics
more
of the
than me.
contest you're gonna have to you'll find out later when it gets closer to there, right? But then like where it's gonna be hosted, how it's gonna work, all of those things I'm not 100% certain, right? But you should be informed closer to the date.
Okay, thank you.
So over here, some of these exercise questions, you're also gonna have to know kind of how to how do I say this? You're also gonna have to know how to essentially like figure out specific aspects. So for example, everything that we've done so far, we based it off of the fact that uh we based it off of the fact that the numbers always start at 1, right? So I want to find the sum of all the numbers starting from 1. Well, what happens if it doesn't start at 1? What happens if it starts at something else? Right. So for example, if you look at page 71, what is the sum starting from 50? So we're starting from 50 going up to 150. So we're not starting at 1. Right? So now what I want you to do is I want you to try this question. Try to apply Gauss's formula. So obviously it doesn't start at 1. So you're going to have to alter it a little bit. But try to figure this out. What is the sum starting from 50 all the way to 150?
Wait, so before you divided by 2, so you divided it by 2 because
We divided it by 2 because we had 2 sets of those numbers, right? So because what we did was there's 2 rows of numbers. The first row goes from smallest to biggest. The second row goes from biggest to smallest, right? So this is where we start with 150 and we're going down instead, right? When we added all of these numbers together. So because we're adding two sets of the same number, we essentially doubled our sum because we added it twice, which is why we divide by 2.
Second question going backwards from largest to smallest?
Say again?
Is number 2 going backwards?
Oh, these are not questions. These are the 2 different rows of numbers.
Oh,
This is the same question, number 19.
okay.
is it 15,000?
No. How are you guys doing?
The
Anyone
answer is
able to find the answer?
25,000. 25,000.
No.
150,000.
No. Way too big.
Or what?
That's too big.
250. So 300,000 is the result of 200 times 150. 200 is because the first number adding the last number using Gauss's problem solving. And then you get 30,000 from the multiplication. And the product for 200 and 1 times 150 is 300,000, and then 300,000 divided by 2. No, wait, what? Yeah, 2, because you're using two numbers. And the answer for that is 250,000.
No. There's some errors in your calculation,
Oh,
but also no. The fundamentals are also not there.
I give up.
Justin, were you able to do it?
No, I thought I thought it was 15,000, but no, you said it was wrong.
So let's go through this. So remember our formula. We have the sum of n amount of numbers. Actually, let's not do this one. Let's use Gauss's method, right? So we set up the two sets of numbers going from smallest to greatest. This is number 1. We also have the numbers going from greatest to smallest. This is number 2, row number 2. Right? What's the sum of each matching pair? So this plus this plus this, what's the sum?
200.
Sum is 200, right? So the sum is 200. How many numbers are there from 50 up to 150? I think I went over, I don't know if I went over this with you before. If you're given a range of numbers, the easiest way to find how to, like, the easiest way to figure out how many numbers there are in total, you take the biggest number, you minus the smallest number, and you add 1. So in this case, the biggest number is 150. The smallest number is 50. And then you add 1. 150 minus 50 is 100. 100 plus 1 is 101. Right. This is to just a little, as a little note. Find the range of numbers. Range simply means how many numbers are there. Obviously, this is completely dependent that the numbers are consecutive. Each number comes right after another one. So in this case, there are 101 numbers from 50 to 150 inclusive. So my sum is 200. I multiply this by how many numbers there are, 101, and I divide by 2. Right, I can simplify 2 with 200. 100 times 101. Whenever you multiply by 100, you just add 2 zeros to the right of whatever number you have. So I take this number, 101, I add 2 zeros to it. So the sum is 10,100. And this is the correct answer. Does that make sense? So Gauss's method is not only limited to numbers or the set of numbers that start at 1. Gauss's method can start anywhere. as long as all the numbers are consecutive. Right. So, but is that actually true though? Let's think about it. If we look at the next exercise, number 20, find the sum of 2 plus 4 plus 6 plus 8 plus 10. These are all even numbers, all the way up to 60 by using Gauss's method. So again, Gauss's method means we list out all the numbers. So again, I have row 1, which is 2 plus 4 plus 6. Row number 2, the sum of these numbers is 62. I can double check this is 62, 62. Right. So my sum is 62. How many numbers are there? Well, here, this is a little bit more difficult to determine. From 2 to 60, only even. How do we figure out how many numbers there are? Right. One method is you can count all of them. Another method is you can think of it like, well, this 2 to 60, this is the same as saying I'm taking all numbers from 1 to 60. There are 60 numbers in total here. But I only want the even numbers. So half of all those numbers, which are all odd, those are discarded. We don't count them. So we can divide this by 2. That gives us 30. These are just even numbers. From 1 to 60, there's 60 in total. Even is half of all of those. Right. So there are 30 numbers in total. So 62 times 30 divided by 2, following the formula, right? And then what does this give us? So again, we can cross simplify, right? There's a whole bunch of stuff we can cross simplify with. I can do 1 and 15, or you could have cross simplified with the other one, right? Other one would have probably been the easier choice. Let's do that. Right. I say this is the easier choice because this is 30 comes with a 0. So 31 times 3 plus a 0 at the end. 930. And this is actually, in fact, the sum of all of the even numbers from 2 to 60. So Gauss's method still works, even if it's only even.
So for the divided by 2 parts, how do you know which one to divide by? Again?
It doesn't matter.
Oh.
Yeah. But because I'm doing mental math, I'm not actually plugging this into a calculator. All I did is I noticed that this number has a 0, right? And then this number does not. So and they're both even, which means I can simplify with either one. I just chose this one because this one has a 0 with it. Right. But in terms of you guys, it doesn't matter which one. You're gonna get the same answer no matter what. Right. So part B of this question is actually quite interesting. It's the exact same set of numbers. However, it says find the sum by noticing that those numbers is the same as if I were to factor out 2. Right. So I don't know if you guys have learned how to factor numbers. I don't think you have. But out of all those numbers, right? So 2 plus 4 plus 6 plus 60. If I take out 2, if I divide every single one of the numbers by 2, because I've divided everything by 2, I can write a 2 in front of them. 2 divided by 2 is 1. 4 divided by 2 is 2. 6 divided by 2 is 3. Now these are consecutive. Each number comes one after another. So what this is saying is that this is the same as saying, well, I want to find the sum of all the numbers from 1 to 30. And then once I find out what that is, I'm going to multiply it by 2. And you're going to come up with the exact same answer. So don't worry if you haven't learned how to factor before. This is not necessarily a requirement. This is just if you have learned how to factor, here's another pattern. Here's another kind of like interesting fact. So this next part, if we go to page 72, so you're gonna see that there's a pattern of blocks that are put together, right? So over here there is how many here? Like 1, 2, 3, 4, 5. And then you have 1, 2, 3, 4, 5. Probably should have drawn these as squares, but no matter. And then there's blocks all between. But what you want to do is you want to look at all of these blocks in diagonals, right? So if I were to draw diagonal lines from here to here, there's one block that crosses this line. There's 2 blocks that crosses this line. There's 3 blocks, 4 blocks, 5 blocks. So if you look at diagonals, right, it might be better if I kind of colored them in a little bit. So if I use this color, so this is the first row that I look at. So if we look at this like a pattern, well, there's one number, there's 2 of these, there's 3 of these, there's 4 of these, there's 5 of these. So if you were asked, how many blocks are there in total? It's the same thing. This is exactly the same as Gauss's method. So we can apply Gauss's method, right? I can reverse this order. The sums are 6. There's 5 numbers in total. Divided by 2, 15. This is just kind of like a more visual representation of this particular problem. So Let's see here. How long is 5.3? Well, 5.3 is not that long, actually. So let's go over the 5.3, page 73. Right. And what we're going to do, we're going to take a look at 5.3. And we're going to see that this is on the topic of patterns and algebra. How do we incorporate algebra into helping us solve patterns? Right. So patterns of numbers can be generated from algebra. So if we look at the first example, if I gave you the expression 4n plus 1, where n stands for a number, right? Then let's say that I want to come up with the first 4 numbers. So for n, I'm going to make it start equal to 1, 2, 3, 4. So obviously this continues, but let's say I only take the first 4. Let's see what numbers this generates. So for when n is 1, 4n plus 1 means I have 4 times 1 plus 1. This is 5. When n is 2, 4n plus 1, 4 times 2 plus 1 is 9. When n is 3, 4n plus 1, 4 times 3 plus 1. When n is 4, 4n plus 1, 4 times 4 plus 1, 17. So this one expression, 4n plus 1, generates a pattern of numbers that starts with 5, goes to 9, goes to 13, goes to 17, and it keeps going. There's a pattern to these numbers. That pattern is defined by this expression up here. Right. So one other little tidbit is each number in a certain, and this is called a sequence of numbers. But each one of these numbers, these are something called terms. The first number is the first term, second number is the second term, third number is the third term. So if I ever use the word term instead of like first, second, or third number, you know what I'm referring to. Right. The first term is term 1. It's also dignified by t with a little 1. Second number is term 2, which is t with a 2. This is term 3, which is t with a 3, so on and so forth. This is just how we represent numbers, right? So in this sequence, this would be t1, t2, t3, t4, yada yada yada, right? So what we can say is we can write tn is equal to 4n plus 1. So what this means is that this is essentially a formula. If I want to know what the 10th number is, or the 10th term, well, I would plug in 10 for n. So this would be t10 is equal to 4 times 10 plus 1, which is 41. So if I know the expression, I can find out any number in that sequence. If I wanted to find out the 541st number, I can do that by plugging 541 for n, using that inside of this expression. And this is very, very helpful for us. So in any sequence of numbers, this may be a little bit of an overload, but I feel like it's very important for you to know. But in any sequence of numbers, what you have to do to get from one number to the next number, this is called the difference. Essentially, it's kind of like, what do you have to add or subtract to get from the first number to the second number? In this case, the difference is 4. Right? So if you ever ask like what is the difference between terms, this is just saying what has to happen to one term to get the next one. So now we're going to move on to the opposite, right? So here you're given the expression, you need to find out what the sequence looks like. But most of the questions, or a lot of the questions, they're going to be the complete opposite. You're shown a sequence of numbers. For example, 5, 12, 19, 26, 33, 40, right? And you're asked, given this sequence of numbers, what is the expression that comes with this? Right? So now you're given numbers, you have to find the sequence. And whenever this is the case, you're always going to be given at least the first 3 or 4 numbers. Right? So here, let's try to find a pattern. What's the difference between each term? To get from one number to the next number, what do we do?
Add 7.
We add 7. So our difference is 7, right? So because we have to add 7 to get from one term to another term, what we usually do is we say, well, I have 7n. 7 is being multiplied to n, which is the number of terms. If you look back to the previous one, this one had a difference of 4, and this was 4n. Right? Here we have a difference of 7. This is 7n. But 7n, we also have, usually it comes with, we're adding or subtracting a number with it. Because it didn't just start with 7n. We may be adding or subtracting something. In this case, we actually are adding something. Right? So let's look at it this way. I know that this is the formula for Tn, right? Whatever term I want to find out, this is given by 7n plus a number. Right? I don't know what this number is. However, I do know what the first number is. T1, or in other words, 5, is equal to 7 times n plus this mystery number. So 5, or sorry, this should not be n, since we know what n is in this case. This is 1, since this is the first number, right? So 5 is equal to 7 plus this mystery number. So what is this mystery number? Well, I need to figure out what it is. So it's kind of this is essentially algebra. Think of this mystery number like this. If I rewrote this as 5 is equal to 7 plus x, well, if you have to solve for x must be alone, and it also must be positive. Right now, it is positive, but it is not alone. 7 is being added to it. So I can subtract 7 from both sides to get rid of this. 5 minus 7 is -2. So my mystery number is -2. Which means this formula now Tn is equal to 7n plus -2. We can simplify this even further. If I'm adding a negative number, this is the same as just saying -2, right? This is my expression. And the reason why I said that you're always going to be given the first 3 or 4 terms is because when you've come down to this step, we've done a lot of work so far. I need to confirm that this expression is correct. This is actually true. If I only have the first number, of course it's going to work. I use the first number to find this out. But I don't know if that's going to work for every other number. So let's check. What's the second number? 12. So T2, which is 12, is equal or should be equal to 7 times 2 minus 2. So 12 is equal to 14 minus 2, which is 12. That works. Let's check another number. Let's check the third number. T3, which is 19, is equal to 7 times 3 minus 2. 19 is equal to 21 minus 2. 19 is equal to 19. This also works. You can keep checking more and more and more numbers, but you'll come to the conclusion that yes, this expression is correct. It's spot on. So we can say that the expression to represent all of these sequence of numbers is 7n minus 2. Does that make sense? Any questions? Okay, let me just double check something before I get any further.
What's going
Just
on?
just bear with me. I'm looking up what questions to give you for homework. So what I will do is I will take a picture of this. Whoops. Did not mean to do that. Okay, so check the Zoom chat. Should have just sent you a picture. This is a picture of all the questions you have for homework. Right, so please make sure you save the picture or you have written down what the questions are. Either one is fine. With that being said, are there any questions before we end the class? So if there's no questions, then I will see you guys next week. Right, bye-bye.
Bye.